Hi everyone. In this video, we are going to solve a problem. The problem name is flip string to monotone increasing, and the problem number is 926. So guys, let's quickly see what this problem say. A binary string is a monotone increasing if it consists of some number of zeros, possibly none, followed by some number of ones, also possibly none. So let's say I have a binary string, means that it contains only 0 and 1. And if it contains both 0 and 1, then we can say all the zeros should come before 1. So let's say this is a binary string. So this is not monotone increasing, but if I make it all 0 before 1, then we can say this is a binary monotone increasing string. I hope this much is clear to you. Now let's move to the next line. It says you are given a binary string as you can flip s of I, changing it from 0 to 1 or from 1 to 0. Here what it say? It says that we can flip a particular character from a binary string. We can say if we have this binary string, so we can either make this 1 to 0 or we can either make this 0 to 1, right? If I make this 1 to 0, if I make this 1 to 0, then what I'm getting 0 0 0 and 1, right? And this is also binary monotonic increasing. We can say all the zeros are before 1. And if I make, let me make again, if I make this 0 to 1, then again I can say that this is binary monotonic string, right? All the zeros are before 1. Now guys, there is one more line. Return the minimum number of flips to make s monotone increasing. Now we have to return the minimum number of flip we need to require to make a binary monotone increasing. So guys, let's see the first example and see how we can do this. So I'm going to remove all these things. And here we have first example 0 0 1 0 0. Now guys, here we can say we need to just make this 0 to 1 and we get our monotone increasing binary string, right? And in the second example, we have 0 1 0 1 1 0. And here either we can make this 1 to 0 and again we can make this 0 to 1. So we will get a binary monotonic string 0 0 0 1 1 1, right? But there is another way also. We can say like 0 1 0 1 1 0. This was our binary string. Now we can say either this you can make this 0 to 1 and also this 0 to 1. You will get again a binary monotonic string, right? Now guys, this was the problem. I hope you understood now problem. Now let's quickly see the logic part, how we can solve this particular problem. So let me write here logic now. And I'm going to take a first same example 0 1 0 1 1 0, right? And I'm going to take two variable. First is 1. It will tell us that how many 1 has occurred in a binary string. And second is nothing but count, which will tell us that how many flip we have done in our binary string. Okay. So initially I have 0, means no one has occurred. So keep in mind guys, we want to keep 0 ahead all from all the 1, right? So what we can say, if you are getting a 0 initially and there is no 1 occurred before that, so keep moving ahead. We don't want to replace or flip that, right? So here we got 0 and we can say that 1 is 0 initially and count is 0 initially. So 1 is 0 means we don't have 1 right now in our binary string. So move ahead. Now we got 1. Now if we get a 1, that means we can say increment over 1, means we got 1 1. Okay. And after that we got 0. Fine. Now here we can say we have 1 is equal to 1. That means 1 has occurred before this 0 variable, right? So what we can do, we can say either you can make this 0 to 1 or you can make all the 1 before 0. There's only two possibilities. If you make all the 1 before 0, then also it will become binary monotonic string for right now. If you are making this 0 to 1, then also it will become binary monotonic string, right? So here I can see that my 1 has occurred only one time. So it will take only one flip if I make all the 1 to 0. If I make this 0 to 1 also, it will take only 1 unit of time, means one flip. So I can say, so let me make it 0 to 1, right? So I can say I have flipped one particular character and I make it 0 to 1 right now. Okay. Now guys, we will move to the next one. Here we got 1. And if I am getting 1, so I keep simply incrementing it. So I got 2. 1 is equal to 2 now. And I got again 1. So I will say now 1 is nothing but 3. 1 has occurred 3 times in my string. Okay. Now again I got 0. And here I can see that before this 0, I have 3 1, right? So it will be hard to make them 0 all. It's simple to make this 0 to 1, right? So I can say now my count is nothing but 2. So I have flipped two particular character. I make all the character 0 to 1 and I got my more binary monotonic increasing string, right? So if it is not clear, let's take another example, that is triple zero, double one and triple zero. Here you will see when we need to make a 0 to 1 or 1 to 0, right? So here initially 1 is 0, 1 comes 0 time and count means we haven't flipped any string. Okay, and initially we were here and we can say 1 is 0, 1 hasn't occurred, so keep moving. 1 hasn't occurred, keep moving. But here we got 1 occur, so we will increment this 1. So I got 1. Here again 1 occur, so I will keep incrementing it. 1 come 2 times. Now here 0, we can say 1 has occurred already 2 times in the string, right? So now should I make all the 1 0 before this or should I make this 0 to 1? Here I can make it because I can see that 1 has occurred 2 times, and if I make this 0 to 1, then I just need one flip, right? So I can say I am going to make 0 to 1, right? Fine. I come to here. Again, I can say that either you can make all two ones to 0, or you can either make this 0 to 1. So I can say that okay, make this 0 to 1. I could now count 2. Again I come to here. I can see that either you can make all the one which has occurred before this, that is 2 times occur. You can make all that 2 to 0. Otherwise you can make this 0 to 1. If I'm making the 0 to 1, you can see I'm getting a count 3, right? If I make this 0 to 1, so I can say I need to flip 3 times to make this binary monotonic string till this particular character, right? But if I make all the one which has come before this, this is telling by this one variable. This means that we have already seen 2 1. So if I make this 2 1 to 0, that means this 2 1 to 0, then I just need to flip, right? So I can say that one condition, if my 1 is less than count. Now here I can see 1 is less than count. That means 1 occur less time than more flipping from 0 to 1. Then I can say count is equal to 1. I can say guys, count is equal to 1. Count should be 2, means I have flipped all the 1 to 0 till this particular character. So now my count equal to 1. That means I can say till here I have now nothing but this 1 is also 0, this one is also 0. So this is nothing but my binary monotonic string. I hope this much is clear to you. If it is still not clear, let's see the code part and see how we can implement this particular algorithm. So here guys, first of all, what I'm going to do, I'm going to take two variable, one and count. Initially both are 0, right? And I'm going to traverse my particular string. So I can say for character in string. So let me write this. Here what I'm going to do, I'm going to say if character is 0, fine. If character is 0 and if 1 hasn't occurred before it, so if 1 is also 0, that means we can continue it, right? We can say continue because 1 hasn't occurred before this. So we can say continue. But if 1 has already occurred, 1 is not 0, then we can say make our count place equal to 1, right? We want to make from 0 to 1. Okay. And if character is not 0, if character is 1, then what we can do, we can simply say 1 plus equal to 1. And now guys, after this if else condition, we can say if now my count become greater than 1, or we can say count 1 is less than count, we can say simply count is going to equal to 1. I hope this much is clear to you. Now simply we can return our count. So I can say return count. Let's quickly run this code and see whether it's working fine or not. You can see guys, all the test cases are passed. So let's try to submit this code. And here we go guys. I hope this much is clear to you. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.